Hello dear student, very good morning to all of you and welcome to our first class of geography and second class of our OPSC and UPSC foundation class. In this class we are going to cover your entire once again. Uh, Hello dear student, very good morning to all of you. So this is our second class of foundation batch and first class of geography. So in this foundation class it will be helpful for OPSC, UPSC and other state PCS students. So this batch is started 21st August. This is our second class. You can see this batch is available both online, offline and hybrid mode. We are going to cover your entire GS, prelims as well as mains. We are going to cover your essay. We are also going to cover CSAT, Odisha specific content. You will get free mentorship under this program, prelims test series, study material, everything that you will get in this single package, like from starting to end. We are going to cover in this foundation class, and you can see this is what the course that we are providing to in this foundation class. Just an you can say about what are the things that we are providing. NCERT foundation we are also going to cover under this class also. One-on-one mentorship, recording classes also available. Next is you can see our faculties. So they are the best faculties you will get at comfort of your home. So you can see Smriti Ranjan Mishra, Avdesh sir, Pradeep sir, Shrikant sir and Asutosh sir, and Madhumita ma'am, Idvir sir is also there. So the class mode, it's both online, offline and hybrid mode. So price is very nominal. So limited seats are available. So you can join. You can contact our number 72176 30385. Okay, so this is what the unique thing that we are providing: expert faculty, small batch and quality study material compared to none. So recording lecture you will find, and CSAT is also included. So one program you will get everything. So we are also promoting our student interest and all. Okay, chaliye. So very limited seat is available and EMI option is also available. You can join to get all this benefit. Okay, so you can contact in this number 72176 30385. Chaliye. So today we are going to start from geography. Why we are going to start geography? Geography is quite easy and it is very interesting paper. Here no need to do lot of ratification. By understanding the concept you can write very good answer. You can also get lot of prelims. You can solve lot of prelims question also. So before starting, what are the things you need to follow or how you are going to approach the class? That is what I am going to explain. Dekho, whatever I am discussing in the class, so you have to study. So already I have given you extensive PDF, already I have given to all my foundation batch student. So this PDF you have to study. You have to study the PDF. Let's say I have completed today interior of the earth, then you have to complete everything whatever I have discussed in the class. And then if I am doing some value addition, I am writing some in the let's say screen. So value addition. So please note down that. Note down on the side of this PDF. You can make printout of this PDF. You can note down if I am adding something additional, or you can add in a piece of paper. Later you can add to this notes. Okay. After studying this PDF and making notes, the value added thing that I am saying, so no need to go anywhere. This note is very comprehensive. If you are not getting, if after studying that you are not getting any question in UPSC, then no one will going to solve that kind of question. So that means it is very comprehensive. I have tried to incorporate everything in this PDF. So this is more than enough for your prelims, mains, okay, of your GS. And apart from that, you have to download Google Earth. Okay, Google Earth is for mapping. Dekho, traditional way you should not use the map book. It will take lot of time. What you can do, you can take blank pages where there are map pages where maps are there with blank. So you can use one map for, let's say, mountain, one map for river. Okay, so you can use your Google Earth to find out rivers, to find out the location. Yes, you can purchase one map book. So there you have to practice whatever location I am giving. So geography is all about mapping and locations. Okay, so Oxford map or Orion Blackswan map you can purchase. Okay, online version if available you can do that, but offline is good. You know, you have to purchase a book, and whatever the location I am giving, you can either refer to the Google Earth. Google Earth will take you to that location in just 10 seconds. So that is the reason you can fast track your preparation. At the same time, you can also mark that in your mapping book, and you have to keep on practicing. There is a blank map book available in Amazon, Flipkarts or Google. Just search it and purchase it. There you will find lot of India map, lot of world map. From there you can repeatedly practice all this mountain, river, okay, ocean current. So if you are practicing repeatedly, and if you are having this map at your disposal, you can easily revise before your examination, and this mapping is going to be game changer. Last couple of years they are asking a lot of questions from the mapping. Okay? So this is what mapping and notes. So let's say after doing, after you have completed one reading, so what you have to do, let's say you are doing daily 3 hour, let's say you are doing daily 4 hour of study. Let's say you are after I have covered any topic, so you are doing 4 hour of study. So out of that 4 hour, my suggestion is that study for 3 hour and try to write the gist, try to write the summary in 1 hour. Why you have to write your summary? If you are writing your summary, then it will improve your retention skill. It will improve your retention skill, and that skill is very much essential, because if you are writing, that is also going to improve your answer writing skill. The more you write this summary, it will force you to study more, because we are studying 3 hours, but we are studying in casually, not remembering. If once you are making that you can say in a summary way, so that you have to, while reading, you have to be very focused. You have to remember the facts, figures and diagram, then you are going to be very much useful. And one more thing, dear student, you have to, those who are giving UPSC, for UPSC student, you have to start, make sure that you should draw the world map. I will teach you how you can draw world map and India map. And those who are giving state PCS, if you are giving state PCS, any state, if you are giving, let's say OPSC, Odisha State, Odisha Public Service Commission, or OPSC, then you have to know how to draw world map, India map and Odisha map. And you have to practice that in 30 times today only. You have to practice the world map 30 times today only. If you are giving BPSC, then you have to draw Bihar map. If you are giving UPPCS, you have to draw Uttar Pradesh map 30 times. Okay? Without mapping, without diagram, geography will not fetch much good marks. Okay? Geography is not about ratification, it's about clarity of your concept. Okay? So this paper is quite scientific paper. So you will enjoy if you start reading in a systematic way. Okay? Chalo. Chaliye, as time proceed, gradually I'll tell you how you are going to proceed further. And one more thing, the PYQ. Dekho, PYQ importance is very much, because it is like compass. For me, the PYQ is like compass. So for that reason, you have to refer to the UPSC. If you are giving, let's say UPSC, you can refer to the UPSC prelims PYQ, mains PYQ. If you are giving to the OPSC, or you are preparing for OS or OCS, then you have to refer to the prelims PYQ, mains PYQ. Then only you will be able to understand what kind of question they are asking and how you are going to study, how you are going to make the note. Like they are like GPS to guide you to reach a definite location. So that is the reason. So keep on referring to the PYQ. So if you want the PYQ, you can download our application, Strivage IS Academy application. So here the link is given. So you can download this Strivage IS Academy. It's available in the Play Store. So all the PYQ available either free of cost or at the 1 rupee. So from there you can get all this PYQ, and you have to refer this PYQ daily at least 30 minutes. Then only you can streamline your preparation. The two things, if you know about the syllabus, if you know about the syllabus plus PYQ of prelims plus mains, believe me or not, you already completed 20 to 30% of your syllabus, and 95% student don't do that, okay. And if you referring to this syllabus and PYQ repeatedly, so daily you will save around 3 to 4 hours, because you are very streamlined. You are not end of reading everything whatever coming on the way. You will prepare what is required for you, okay. ठीक है, so चलिए, this is what I just want to inform you, so that it is going to be very helpful for your preparation. So let's start with this diagram. This diagram is very important. So geomorphology means the changes that we are seeing on the earth surface. Okay, for example, we have seen that there are mountain, there are waterfall, there are volcanic eruptions, there are oceans, there are oceanic trenches. Trenches means deep inside the ocean. So how they are happen? So this mountain like Himalaya mountain, today we are seeing they are having 8-kilometer high. This is not happen suddenly. They happen with a lot of time, lot of internal process is there. So because of that this has happened, and this process of happening is called geomorphology process, geomorphic process. So whatever we are seeing on the earth surface, it is, if it is mountain, if it is plain, if it is plateau, all these things are happen because of this geomorphic process. So if you see how this geomorphic process started, this is started because of two forces. One is acting inside the earth. This is what called endogenic. आई थिंक आपको पता होगा, आपने देखे होंगे डॉक्टर मेडिकल में बोलते हैं ना एंडोस्कोपिक. एंडोस्कोपिंग मीन्स टेकिंग फोटो इनसाइड द बॉडी इज कॉल्ड एंडोस्कोपिंग. So if something is happen inside the earth, we can call this as a endogenic movement. Let's say this is the earth. If something happen inside, this is surface of the earth, this is surface. If something is happen inside the earth, then we can call this as a endogenic force. Okay, endogenic force. And exogenic force means something that is happen on the outside the earth. What is the outside earth? On the surface of earth, whatever happening, this is called exogenic. Exo means bahar, exogenic. ठीक है, endogenic and exogenic force. Hope it is clear. So let's move further. So within this endogenic, that is force that is operating within the earth, it is further divided into diatropism. Diatropism means slow deformation process. For example, a mountain is built slowly. I can give you an example. Let's say this is the crust, earth crust, and this earth crust is being folded. Let's say this paper is the earth crust, and because of this force, maybe this gradually lifting like that. Okay, so this is what slow process of deformation on the earth surface we can call diatropism. This is very slow, gradual. It will take millions of years. Even the Himalaya today we are seeing as a 8-kilometer height, it is not happen all of a sudden. It is happen because of slow, gradual process of, देखो, two plates, one is Indo-Australian plates from the bottom and Eurasian plate, they collide, and the gradually this is rising like mountain. Okay, this is what happened actually. So next one is sudden movement. Sudden movement means that is happen in few seconds. For example, earthquake is happen, अचानक से earthquake होती है. Next is volcanism or volcanic eruption. So endogenic force is divided into diatropism means slow movement, and second one is sudden movement. Okay, within this diatropism it is called epirogenic. Epirogenic means when, let's say this is the surface of the earth, if it is uplift, there is a deformation in a, you can say, spherical shape, or if this is plane surface but it is like that, this is what called up warping, down warping, or there is a rising a portion or falling a portion, that is what called epirogenic. Epirogenic is two type of upward, that means this is what called upward, and downward means plane surface, there is a movement of downward. Okay, so next one is called orogenic. What is the meaning of orogenic? Orogenic means mountain building force. So mountain building force can be tension, it can be compression. So tension means what? Let me show you. Let's say this is a plate. If we push on the both sides, so this is what called compression, led to the deformation and rise of mountain. And if I start pulling this page on the both sides, so there will be break down, and because of that land will be fall, and that is create fault mountain. So we are going to see all these things detailed. So orographic means mountain building force, and mountain building force can be tension, and mountain building force can be compression. So tension led to the formation of fault mountain. We are going to see how, don't worry, this is just an introduction. And compression led to the fold mountain like Himalaya. ठीक है? So this is what the the starting. So as we proceed, I think you will not have any doubt. You might find at this point little bit of difficulty in understanding, so don't worry. As we proceed, so you will not find any difficulties in this. चलिए, so next you can see we have discussed about the endogenic, that means force that is acting within earth interior. Now we are going to see exogenic. Exogenic means the forces that is acting on outside the earth. So that can be weathering and erosion. So what is the weathering? Weathering means, देखो कोई एक मटेरियल और कोई रॉक पड़ा हुआ है. So what do you mean by weathering? Weakening and falling is called weathering. So that means this, you can say weathering means disintegration and decomposition of parent rock is called weathering. क्या आएगी? Disintegration means big thing can be fall apart there. वो एक बड़ा सा चीज़ है जब टूट के वहीं पड़े होती है, and after that decomposition means material they are washing away. That is what led to the weathering. And weathering can be physical. Physical means wear and tear. It can be chemical because some acid can do weathering of the rocks. It can be biological. For example, आपने देखे होंगे बहुत सारे पेड़ क्या करते हैं, अपना रूट रॉक के अंदर घुसा देते हैं. So because of that they break rock into multiple parts. ठीक है? So biological. Then next is erosion. So after weathering means what? The parent material, the parent rock is being disintegrated and decomposed, and then fall from that place. From that place it is moving from one place to another place. This is what called erosion. आपने देखे होंगे बहुत सारे जब ना whenever there is a severe rainfall, whenever there is a severe rainfall. So dear student, my voice is audible or not? Everyone please confirm me, my voice is audible or not? So erosion means moving of weathered material. Let's say this is a big mountain. This is a big mountain, and because of this weathering, so this parent material fall here on the bottom, and because of rainwater, this is rainwater and this is wind, so they wash away from one place to the another place. This is what called erosion, and this movement erode material from here and deposit from here. They erode from one place and deposit from another place. So what are the agent of erosion? The erosion can happen because of ice. Ice is quite active in high mountain region, and also in the Arctic and Antarctic region. So next is river water. So river water also bring lot of sediments from upper course and deposit on the down course. So it can also found on the seashore. So I think whenever you visit to a sea, so like coastal area, you can see lot of sands are there. So sands are because of erosion and depositional activity. So next is wind. So if you ever travel to a desertic area, you will find that this is what found because of wind deposit lot of sands. Then underground water also erode lot of material, and they erode from one place and deposit in another place. So this is what about the geomorphic process. So entire geography, most of the geography, physical geography, we are going to discuss this diagram only. So as you proceed, there will be clarity of your understanding. Even if you are not able to understand at this point in time, so I will keep on referring to this, you can say the diagram multiple times. So you will have the clarity. चलिए आगे बढ़ते हैं. So we will start from interior of the earth. After that, after some time, we will see the origin of universe and earth. Okay, चलो आगे बढ़ते हैं. and solar system, then Earth, everything we are going to see after some time. First, we'll start from interior of Earth. Yes, we'll start from here. So interior of the Earth. देखो, one thing that raise always the curiosity of the scientist or all the geographer कि whether Earth is just like a onion or it is something else. ठीक है, it's like shape of the Earth कैसे होना चाहिए, क्या solid ball और it's a like concentric layer just like the onion. Onion जब आप तोड़ते हो क्या आती है, layer by layer आती है ना. सबसे बड़ा डाउट थी कि जो अर्थ का जो इंटीरियर है एक सॉलिड बॉल है या फिर मल्टीपल लेयर बाय लेयर जस्ट लाइक द ऑनियन. सो आफ्टर दैट ऑल दिस जियोग्राफर, all the geologists, they conduct lot of scientific experiment, and after that one of that study is called seismic study. Seismic study, so there we are going to see that in detail. So the seismic study help us to identify that Earth is not like a solid ball, it is consisting of multiple concentric layer. What are these multiple concentric layer? The outer layer is called crust, the outer layer is called crust, and second layer is called mantle, and third layer is called core, and further the core is divided into inner core, outer core, and again the mantle is also divided. But for time being, understand that Earth interior is not like a solid ball. For example, जैसे for example if you can take a big ball आप ले सकते हो, कोई एक spherical ball ले सकते हो, उसको काटोगे तो क्या मिलेगी, पूरा का पूरा वो solid मिलेगी. But if you cut this Earth into pieces, you will not find a single metals, rather you will find like a layer by layer structure like the onions. And what are that layer? First one is crust, second one is mantle, third one is the core, and inside core what you will find? Inner core and outer core. Hope it is clear, and if it is clear please let me know. Please comment in the comment box if my audio, video, everything is okay or not. चलो आगे बढ़ते हैं फिर. ठीक है, you can see the Earth interior is divided into crust. Outer layer is called crust, middle layer is called mantle, and inner layer is called core. Okay, so this whatever I am writing in the box, they are very important, so you can read that. The core of the Earth only occupy 15% of Earth volume, whereas mantle occupy 80% and crust occupy 1%. From here there can be a question according to the volume. There can be question, arrange on the ascending on or descending order of volume occupied by crust. One option there will be crust, though mantle, core. Arrange these three option on ascending or descending order of volume they occupy. सबसे ज़्यादा तो volume, largest volume being occupied by mantle, then core, and then crust. So I can write 2, 3, 1. This is the correct sequence. So like this way, whenever you are reading something, you have to identify what are the possible questions they can ask. Then only you can streamline your preparation and you can get lot of benefits without putting much hard effort. Okay, 1 second. Okay, so next thing is that the source of information about the Earth interior. So I have already told you the Earth interior is just like onion, so layer by layer. Then the big question that might comes to your mind, so आपको कैसे पता चला, मतलब मेरे को या फिर जियोग्राफर को कैसे पता चला कि आपने अर्थ का इंटीरियर तक गए थे या फिर जियोग्राफर या फिर जियोलॉजिस्ट अर्थ के इंटीरियर तक गए थे? Answer is no, because if you move inside Earth, temperature will be increased. At after 5 or 6 kilometers, the temperature is so high, it is unbearable. Then the question is, अगर geographer नहीं गए हैं, then geologist नहीं गए, then how come you are saying that Earth interior is layer by layer structure? कैसे आपको पता चला? क्या भगवान ने आके आपको बोल दिए या फिर आपको स्वप्न में आ गया बोल दे रहे हो? No. Geography is driven by evidence, it is driven by science. So there are multiple sources. By reading, understanding that sources, we can have idea about what our interior of the earth is like. So this source of information about the earth interior is divided into direct source that we can directly see, directly observe. For example, the surface, rocks and minerals. So it represents the most accessible geological material, because whenever there are rocks found on the surface, these rocks are nothing but they once existed interior of the earth, inside the earth, with passage of time like erosion and weathering. So this inside rock gradually move to the surface of the earth, and this surface rock is providing us an opportunity to examine what inside the earth. Okay, so this is what the first you can see, the petrology. Petrology is basically study of the rocks is called petrology. So study of rocks. ठीक है, and geochemical analysis in laboratory, scientists stimulate the temperature and pressure condition of earth deeper layer. So by doing all this experiment, we are having idea about what are the composition of earth interior. So next is mining activity. I think you know that whenever we are doing underground mine, sometimes you travel up to 5 km and 6 km deep. With going inside the earth, it is being observed that the temperature is increased. As you move downward on the earth, temperature will be increased, pressure will be increased and density will be increased. So क्या क्या चीज़ें आपको बढ़ेगी? Temperature. As you move downward on the earth or inside the earth, temperature will increase. Next one is pressure will also increase. Temperature, pressure and density will be increased. So by using that, it is clearly they are helpful for constructing idea that as you move inside the earth, gradually temperature, pressure and density will be increased. Okay, so the mining provide another direct methods of assessing subsurface material. However, even in the mining activity there are limitations. For example, only the mining activity we can carry up to 5 km, because at that 5 km temperature is so high that is unbearable for anyone to survive that temperature. Okay? So next one is about the deep ocean drilling project. So project like that is conducted in Kola. So you can see deep, we have bore hole deep inside the earth to understand, but after going certain distance it is found very difficult because of high temperature. Like if this is the rod that we are boring inside the earth, but if temperature is very high, then it is going to melt on the tip of this bore. So after a point of time we are not able to bore deep inside. So that is also the during this boring, so lot of material we have brought to the surface, and we have having the idea as we bore inside the earth. So what are the change in the chemical composition, rock composition? So that is what very much helpful to understand what are the internal composition. So maximum deep boring we have done to up to 12 km. After that temperature is so high that even the pipe, the boring equipment, they itself melt down. Okay. So dear student, hope my voice is audible to everyone. So if you have any not audible, please let me know. So next is about the volcanic eruption. So what happened in volcanic eruption? So this is what, let's say this is a crater on this and this is inside earth. So lot of volcanic material, let's say they come out of earth's surface and they fall down on the surface of the earth. This is the surface of the earth. Whenever this material falling on the surface of the earth, so this provide an opportunity to study them, to understand what are the composition of material. So all this volcanic eruption, they are coming inside the earth to the surface, and they are providing an opportunity to understand what are the composition of these materials. Okay? So and you know, this is what providing information about the internal composition. The volcanic activity offer a natural glimpse of earth inner working during eruption. So magma from the beneath the surface. So magma, the material through which the volcanic eruption happen is called magma. Okay. So and when it is coming to the surface, it is called lava. So allowing the scientists to analyze the chemical and mineral composition. Despite its value, this method does not clearly reveal the exact depth which magma originates. So there are some limitation on each and every methods. So ultimately the seismic study is really providing information about the earth interior. So these studies are only supportive, so they are not providing conclusive evident. Okay? Some of the indirect sources like meteors. For example, whenever there are meteorite impact, there are meteorite is coming on the surface of the earth, so there you can see the meteors are formed same as the our solar system is forming. So same material our solar system is forming, the meteors, the asteroid, they are forming. So whenever they are coming into the earth, they first glow off and burn some of the part, and remnant of that meteor can provide important source of information to us, and by studying that we can understand what is the earth composition, because the same meteor they are forming, the meteor and earth they are forming from same parent material. So if you cut this meteor, so definitely you will find their composition changing as same as earth composition. Definitely they provide some of the clue about earth interior. And whenever meteorite they are coming from you can say a space to our atmosphere, because they are entering at a very high speed, lot of frictions are there, and because of this lot of friction, so they partially burn down, and remaining portion they fall on the earth surface, and this remaining portion is very much, I think आपने देखे होंगे कभी कभार नाइट में ग्लो आ जाता है. This is what happened because of meteorite. Okay, so dear student, just give me 1 minute, I'll just come back. चलिए आगे बढ़ते हैं. So this is what about the direct sources. Some of them are indirect sources. So that means we are not seeing them directly. We can understand them through indirect means. First one is meteors. Second one is gravitational, gravitational measurement, or this is what we call gravitational anomaly. So what do we mean by gravitational anomaly or gravitational measurement? So gravity, if you see about the force of gravity, there is a formula, it's called G, force, gravitational force formula is Gm by r square. So gravitational force formula is Gm by r square. So what is G? Gravitational constant. What is M? M is the mass of body, and r square is the distance between two bodies. If two bodies are there, mass m1, mass m2, this is the distance between two bodies. So the gravitational force exerted by this body is Gmn by r square. Okay. So in earth interior, so if there are dense material, so if there are two materials, or here it is dense material, here it is light material, so there will be more gravitational force exerted by this heavy body because its mass is capital MM. And if it is small body, small m, so having less force. The more it distance, less gravitational force. So by studying this earth interior, we generally found that different location is having different mass density. So mass is different. When mass is different, then the gravity is also going to be different at different places. Okay. So this gravity difference help us to understand that earth interior density is not constant, and different location you can find different type of material. Okay. So next one is about the earth magnetic field. So magnetic field study. So while having magnetic survey, we find the variation in earth magnetic field. So this field is varying depending on the magnetic material availability in different structure. So next one important thing that help us to identify the real interior structure is about seismic activity. So seismic activity में हम क्या करते हैं? I'm just going to show you. So generally, let's say there is a earthquake happening, and whenever there is a earthquake, so different wave will move all this direction. देखो, whenever I'm shaking, let's say I'm shaking here. So if I'm shaking here, there will be a vibration, and this vibration will happen because of movement of waves. Whenever you are throwing a stone in the pond, so you can see ripples of vibration happening on the surface of the earth. Why this is happen? So whenever you are throwing a stone to a pond, so you will see ripples of vibration. Why this is happen? Ripples of waves. Why this is happen? Because of vibration is there. So if there is an earthquake, so there will be ripples of vibration, and this vibration is traveling in the form of waves. And first initial wave that is traveling in all directions is called P waves, and after some time the wave that is traveling called S wave. By studying this primary waves and secondary waves, we are going to see that in detail with their characteristics and a detailed process. So that is going to be very helpful. Don't worry, in geography it's like mystery. Geography is all about mystery. As we proceed gradually, it is going to unlock all your mystery. You have to have the patience and watch this class till the end. You will get all these insights. Okay, chalo. Okay, so understanding this E wave shadow zones and S wave shadow zone help us to make sure that Earth interior is not like a single solid ball. It's like a concentric layer like onion. Okay. Chalo. So what are the layer inside the Earth? Already we have discussed. So first one is called crust. Okay. Second one is called mantle. So outer layer is called crust. This inner layer is called mantle, and सबसे जो अंदर आती है उसको हम बोलते हैं कोर. एंड कोर इज फर्दर डिवाइडेड इनटू आउटर कोर, इनर कोर, एंड इवन द मेंटल इज आल्सो फर्दर डिवाइडेड इनटू अपर मेंटल एंड लोअर मेंटल. सो लेट्स सी डिटेल अबाउट ऑल दिस थिंग्स. सो क्रस्ट is the earth outermost solid layer. Despite being the layer we live, it represent only 1% of earth volume. So सबसे जो पतला चीजें होती है वो अर्थ का क्रस्ट ही होता है. सबसे थिनर चीजें जो होती है वो अर्थ का क्रस्ट होती है. इट इज ब्रिटल इन नेचर. ब्रिटल मींस इट कैन बी ब्रेक डाउन इफ यू either compress or put tensile strength in nature, and characterized by relatively low density. Density means how tightly packed. I am giving an example. If you take let's say you can take this bottle, if you fill water up to here and if you fill honey here, there will be, let's say forget about that. If I am putting here some iron ball inside this bottle, and on the other hand same bottle if I am putting the you can say the cotton, so which one will have heavy weight? Here the iron ball will have heavy weight because dense. They are, each and every ball is densely packed. But in case of cotton, so they are not densely packed because they are loose. If you compress the cotton, this much cotton can be compressed within this much size. So that means they are not that dense. But in case of iron ball, each and every ball you cannot compress. So they are densely packed. So densely packed is having high weight because all these atoms, they are very close. Okay. So here you can see the material that we have found on the surface of the earth, that is the crust of the earth, they are not that denser. So they are lighter material like aluminium, silicon are found on the crust. So that is the reason generally it is said that Cr, silicon and aluminium are found on the crust. क्या हमें मिलता है crust में? Silicon and aluminium. So that is the reason we call earth crust is composed of Cr. Okay. चलो आगे बढ़ते हैं. So you can see low density compared to the layer beneath. So you can see the earth crust is further divided into two type of crust. So first one is about the continental crust. Second one is about the oceanic crust. So what do you mean by continental crust? The crust that is found on the continent, देखो on the land, the surface, whatever the crust we are founding on the beneath the land is called continent. Continent means a land that is being surrounded by water on the four sides is called continent, and India is called subcontinent because it is surrounded by water on three sides. So continent means land, crust. Oceanic crust means the bottom of the ocean. See, the crust that is found on the bottom of the ocean is called oceanic crust. So what are the characteristics you have to identify or remember? Thickness. So average thickness is 30 km in case of continental, but it can extend up to 70 km in mountain range like Himalaya. So here you can understand that all these big mountains, so in their core, so there lies what? There lies the continental crust with thickness 70 km. Generally in plain area the thickness is 30 km, but on the core of Himalaya mountain, this is the Himalaya, and the core of this Himalaya mountain, the crust is 70 km. You can understand, remember that. So from here there can be questions. So the maximum nowhere in the world the thickness, continental crust thickness is more than 30 to 40 km. The answer is absolutely wrong, because in fold mountain the crust there is up to 70 km even found on the Himalaya also. So from here question can be clear. ठीक है, चलिए आगे बढ़ते हैं. So next thing is about the oceanic crust. The oceanic crust, you can see average thickness is 5 km. From here question can be, very tricky. So there can be question like match the following type, all these things. So you have to remember that ocean crust is thinner, but continental crust is thicker. So this is what the first thing you have to remember, the difference. So next is density. So density means I have already told you how the atoms are tightly packed. More atoms are packed in a small area. For example, I am taking this small bowl. Let's say this small bowl. If I am putting all this iron ball up to here, so there will be high dense heavy. If I am putting half iron ball, or I will put some sponge, so there will be lighter. So more denser, heavy weight, tightly packed, light, light dense, or low dense means low weight. Okay. So density, you can see the surface of the earth is having low density 2.7 gram per cm square. If I can take a small volume of a 1 cm material, I can pick and weight, I will get around 2.7 gram per cm square. But here on the oceanic crust I can get 2.9. So I can say oceanic crust is denser than continental crust. From here UPSC or your OPSC or other state pieces, they can ask a question, they can reverse that, they can say that oceanic crust are lighter than the continental crust. So answer is wrong, you have to identify. So composition, what are the composition? So primarily they are composed of granite type rock, so they are called silicon and aluminum. So on that basis it is said that Cl. So generally all the continental rock, they are composed of Ci type, and the composition of oceanic crust is consisting of silicon and magnesium. So they are called सीमा. सीमा कोई लड़की नहीं है. सीमा means silicon and magnesium. मन में खुशी आ गया कि सीमा कोई लड़की होगा ना. No, कोई लड़की नहीं है. सीमा जो है silicon and magnesium. So location, ये कहाँ आपको देखने को मिलती है? From continent and large land mass. So continental crust is found generally the continent like American continent, Australian continent, Asian continent, okay, African continent. So they are formed, Africa is formed on top of this continental crust. Okay, so this oceanic crust, they are formed on the basin, means bottom. Let's say this is a big ocean, this is a big ocean with full of water, and this is what called oceanic crust. This is what called oceanic crust. So underlies ocean basins and sea floor. So they are found on the sea floor of major ocean like Pacific Ocean, Atlantic Ocean, North Atlantic Ocean, South Atlantic Ocean, Indian Ocean, Arctic Ocean, Antarctica Ocean. All these things we have found over there. This difference is very important. Please remember that Then relative properties, they are thicker. कौन thicker होता है? Continental crust are thicker but less dense, but the oceanic crust they are thinner but denser. So this difference you have to remember. And one more thing, at the end I am going to give you a mains question also, so you have to write and submit. Good morning Jagannath. Chalo. So having discussed about the earth crust, so let's move to the mantle. So let's move to the mantle. So what is the mantle? So second layer. So you can see from here to here, it's called mantle. So this portion is called, from crust to core portion is called mantle. Okay, you can see this is what called continental crust. This is what called oceanic crust. And after the crust, so whatever is coming, this is called mantle. Okay. So let's see about the mantle. Mantle is the intermediate layer of the earth situated between crust and core. It is located between crust and core. It is a highly significant region geologically and dynamically. Why? Because all our plate tectonics, all our earthquake, all our volcanism have their origin from mantle. So there can be a question, from which region all this activity like volcanism, earthquake associated with. There can be answer like core, there can be answer core, then mantle, then crust, or to be very precise, it is limited to the upper mantle. So there can be questions. So you have to remember, while studying you should also realize that what kind of question they are asking. And this is my habit that while I am teaching, I will give you the mains and prelims questions. So if you are preparing, if you know this question while preparing, you can note down and keep on practicing on this line. So this is going to be very much helpful for your examination. Chalo. So this mantle is very much important because of all the interior, you can see the all endogenic forces, majority of the endogenic forces have their origin in this mantle. So that is the reason mantle is very active. So let's see. So mantle began at Moho discontinuity. So there are 3 discontinuity and multiple also. So there are 2 discontinuity at this moment you have to remember. One is called Moho discontinuity. Okay? Moho or Mohorovicic discontinuity. This is the crust and this is the mantle, and this shifting from the core, shifting from the crust to mantle, there is a discontinuity, and this discontinuity is called Mohorovicic discontinuity. And there is a discontinuity between mantle and the core, that is what called Gutenberg discontinuity. And there are other discontinuity as well. So we are going to see after that, but these 2 discontinuity are very much important. So there can be match the following type question. There they will give you the discontinuity, and it is found between what? So you have to remember. So Mohorovicic discontinuity is found between crust and mantle. Moho, this is called Mohorovicic or Moho discontinuity, and mantle and core is called Gutenberg. We are going to see Gutenberg discontinuity. And at the end I have given all this discontinuity in tabular format, so you will have to understand all this. चलिए बढ़ते हैं आगे. And dear student, whatever may be your doubt, so you can ask me. So I am going to help you. So mantle began at the Mohoro discontinuity is called Mohorovicic. So this word is Latin word, so it's very difficult to pronounce. So you can remember Moho discontinuity. Okay. So it separate crust from the mantle. So it extend up to a depth the mantle extended depth of 2900. You can see the boundary between mantle and core is called Gutenberg discontinuity. Already I have told you. So there can be a match the following type question. Here they can say Gutenberg discontinuity, Mohorovicic discontinuity, Lehmann discontinuity is there also. One more discontinuity is there. So then they can ask about this is separating between core to mantle, mantle to crust, upper mantle to lower mantle. So you have to remember that. So from there can be multiple match the following type question. Dekho, while teaching, this is what my responsibility is to understand how UPSC is going to frame this question. So this is what I am going to link throughout my entire class. And second thing is that during my class also, I will try to revise the same concept. Even in single class, I will revise the same concept 4 to 5 times, so that at the end you will not able to forget anything. Okay, you will remember everything. So Mantle makes 84% of earth volume, nearly 67% of its mass. So we can say that Mantle is having largest volume and mass is also largest. But the volume is large, but its mass is less. Why? Why this is happening? So tell me in the comment box. In Mantle, though it is having 84% of the volume, but its mass is only 67%. Why this will happen? Because as you move inside the earth, the density of material is keep on increasing. So surface you will get light material, deep inside you will get heavy material, deep in the core you will get heaviest material. So core, though they are having only around 15 to 16% of volume is occupied by the core, it is the heaviest because the core is comprised of iron, manganese, iron, and this is called knife. Okay? So nickel, cobalt, all these things. So because of that, core is heavy and small volume but heavy. So that is the reason here there is a reduction in the mass. Okay. So you can see the average density of Mantle is 3.4. So starting you can see about the crust, the continental crust density is 2.7, oceanic crust density is 2.9, and here you can see the Mantle density is 3.4. So that means as we move inside, the density of material is increasing. So that means we are entering more dense material. Okay? So you can see the Mantle is composed of primarily silicate and magnesium and iron. So you can see here we have seen the crust. The continental crust is composed of Cl, silicon and aluminum. The oceanic crust is comprising of Sima, silicon and magnesium. And you can see the Mantle is comprising of silicon, magnesium and iron. So because of this iron, it increases the density and weight. Okay. So due to dominant of silicon, magnesium, Mantle is often referred to as सीमा. So because of this dominant, but it is different. देखो oceanic crust में भी सीमा था, but oceanic crust में इतना iron नहीं था. लेकिन here there are sufficient amount of iron, so quite heavy. But still it can be referred to as सीमा. सीमा कोई लड़की नहीं है. सीमा means silicon and magnesium. कुछ लोग तो एकदम खुश मन में लड्डू फूटा कि सीमा कोई लड़की नहीं है. चलो, so major rock found on the Mantle include periodite. जरूरत नहीं है. This is very much important. So olivine rich rock. The rock that we found on Mantle, they are called olivine rich rock. So from we can say that continental crust rock are called Cl, then oceanic crust is called Sima, and here it is called olivine rich rock. Okay? So let's see how the Mantle is further divided. You can see Mantle is further divided into two layers. It's called upper mantle and lower mantle. So mantle is further, the mantle layer is also divided into two layers, upper mantle and lower mantle. Okay? So much of the geomorphic activity like volcanism, plate movement, everything is happen on the upper mantle. So for that reason, upper mantle is classified into lithosphere and asthenosphere. So this is very much important. Please remember, here lot of concepts are involved. If you are able to understand this concept, so you will not find any problem in future. ठीक है? चलिए, बहुत important है concept को समझ जाना. So upper mantle के अंदर जो रहती है उसको we can divide that. Upper portion is called lithosphere, and further this upper mantle, for example, this is upper mantle, and upper mantle is further. Let's say this layer is upper mantle, and then lower mantle, and this is further divided into lithosphere. And second is called asthenosphere. Okay? So we are going to see that in detail. So upper mantle further divided into lithosphere and asthenosphere. So it extends from the Moho discontinuity about, that is 35 km to 660 km, and Moho discontinuity lies between crust and mantle. This is the crust layer and this is the mantle layer. So there is lies a discontinuity because let's say let's say whenever, let's say this, there is a water, let's say this is a water and this is my finger. So if I am dipping, so from air I am traveling to water, so that means there is a discontinuity. Same thing happen here. Whenever you are traveling from Crust to Mantle, there will be a discontinuity, and this discontinuity is called Borovicic discontinuity. Okay, so upper mantle, upper layer of this upper mantle, first layer of this upper mantle is called lithosphere. So this upper mantle is further divided into, upper layer is called lithosphere, second layer is called asthenosphere. So it is comprising of crust and rigid uppermost part of the mantle. So thickness ranging from 10 km to 200 km beneath the continent. So this range of this lithosphere is further divided into 10 to 200 km. So it's, this lithosphere is not a single continuous, it is broken into multiple plates. It can be, you can see, the broken into tectonic plates that float on the soft asthenosphere. So that means the top portion of lithosphere is, top portion of mantle is called lithosphere. Top portion of mantle is called lithosphere, and it is not continuous. It is broken into plates, and these plates are floating above the asthenosphere, and astheno means soft layer. So these plates are responsible for earthquake, because whenever these plates they are moving, they are colliding with one another, and because of that earthquake happens, and mountain building is also happen. We are going to see that in detail in future class. That is also helpful for continental drift. What do we mean by continental drift? So if two landmass are there, gradually they are moving away, or if two landmass are away, they can gradually coming together. So this moving away and coming together is called, this moving away and coming together is called continental drift. Okay, so let's see, this is all about the lithosphere. Let's see about the, yes, lithospheric plates. So this lithosphere is not a single, lithosphere is not a single continuous, spherical layer. So rather it is divided into multiple plates. So what are the multiple plates? And this plate is responsible for all the earthquake that is happening all over the world. We are going to see. So dear student, good morning to everyone. Hope my voice is audible, everything is clear. So if you are having any issue or everything is okay, please write in the comment box. So let me know whether everything is okay or not. Okay? So these plates can be starting with Eurasian plates, North American plates, South American plates. This is called Pacific plates. These are major plates. The red, I am writing the red, these are called major plates. It can be African plates, it can be Australian plates. So these are called major plates. And I am writing now in the other color. If I am writing in other color, so these are called minor plates. Juan da Fuca, Coco, Caribbean, Nazca. These are name are very important because these plates play very important role in formation of Andes, formation of Rockies. So for that reason, I am going to discuss anyway. Don't worry, because geography is like a mystery. It's like a box. As we proceed inside, you will get to know about lot of insights. Okay? तो इसीलिए patience बहुत जरूरी है. There are minor plates called Somali plate, Arabian plates, Indo-Indian plates, Australian plate, Philippine plates. So these are called minor plates. So there are small plates, but major plates are North American plates, South American plates, Eurasian plates, African plates, Pacific plates. So these are few major plates. So again I am saying that the mantle is divided into lithosphere. Top layer of mantle is called lithosphere, and bottom layer is called asthenosphere. And this lithospheric layer is not continuous. It is broken into multiple plates, and these plates are given here. It can be North American plates. So let me write in the red color. So it can be North American plates. It can be South American plates. Big plates I have written in highlight in red. It can be Eurasian plates. It can be African plates. It can be Pacific plates. Here both are Pacific plates only. Antarctic plates. Okay? So these are the major plates, and green I have written the minor plates. And this is going to be very much helpful whenever there is a big mountain, whenever there is a big fold mountain, be that Himalaya. Himalaya कहाँ देखने को मिलती है आपको? You are finding Himalaya here. You are finding Andes here. You are finding Rockies here. You are finding Atlas mountain here, you are finding lot of your Great Dividing Range, Ural Range. So all these mountains are associated with all these plate tectonics. How the plate are moving, they are deciding from which region what kind of mountain we are going to get. Okay, चलो आगे बढ़ते हैं. देखो, it's just like a mystery. You will not get everything in one class. As you proceed, I'll make sure that you will be able to understand everything. चलिए. So next one is about the asthenosphere. So bottom layer of mantle, upper mantle is called asthenosphere. What is the meaning of astheno? Astheno means soft layer. Astheno का meaning का क्या होता है? Soft layer. So lies just below the lithosphere, extending roughly from 100 km to 400 km. Depth, the word astheno means weak or soft. ठीक है? So this, it is partially molten and behave in a plastic or ductile manner, allowing the tectonic plates to move over it. आपने कभी ग्रीस देखे हो? ग्रीस क्या होता है? आस्थेनोस्फीयर जो लेयर होता है, दिस इज नॉट सॉलिड. आस्थेनोस्फीयर लेयर इज नॉट सॉलिड, नॉट लिक्विड, रेदर इट इज इन प्लास्टिक स्टेट. आपने ग्रीस को देखे होंगे. ग्रीस क्या होता है? उसके ऊपर कोई भी स्लाइड कर सकता है ना. सो वी कैन से दैट लिथोस्फीरिक प्लेट्स are sliding over the asthenosphere because asthenosphere is just like a plastic state. It is not liquid, not solid, it's a unique state. So that allow the lithospheric plate to slide over the asthenosphere. Okay, so it is the main source of magma. So if there is a question which layer is main source of magma, it is the asthenosphere. That is the main source of magma. And during volcanic eruption, so it transmits seismic waves slowly, confirming its semi-fluid nature. देखो, the seismic wave we have seen there, it can be primary wave, it can be secondary wave. देखो, whenever we are sending a waves, we are sending a vibration. Let's say we are sending a vibration. So vibration can easily travel through solid. Its speed will decrease in liquid. Its speed will decrease further in you can say gas. सो आई थिंक आई गिव यू एन एग्जाम्पल. सो आप बचपन में, हमें आपको याद होगा, एक रॉड लेते थे. रॉड पे हम कान लगा के ऐसे करते ना, माइक लगाते थे ना, ऐसे एक कॉप लेते थे, ऐसे एक कॉप लेते थे. कॉप के नीचे से एक वायर, कॉपर का वायर लगाते थे दूसरी साइड पे. हम कुछ बोलते थे हालो हालो, उधर से वो सुनते थे ना कान लगा के, फिर वो कुछ बोलते थे हम सुनते थे. सो दिस इज व्हाट ट्रैवल बिकॉज ऑफ वाइब्रेशंस ट्रैवल्स थ्रू सॉलिड मीडियम. आप देख सकते हो ट्रेन का जो पटरी होता है ना, रेल ट्रैक. सो यू कैन keep your ear there and listen from far off distance. You can understand whether train is coming or not, because solid can allow the movement of this waves, vibration wave, for long distance and very faster, but liquid don't allow this movement. ठीक है? and gas बिल्कुल बहुत कम allow करता है. so that is the reason we can say the seismic wave, whenever they are traveling through this semi solid or semi-liquid state, so it reduce their velocity. So that is what led to the geologists and the geographer. They conclude that the asthenosphere is consisting of plastic or soft layer. You can see the seismic waves as time progress. After studying about all these waves, so I'll give you the clarity about how it is helpful for understanding what is the structure of earth interior, which one is solid, which one is liquid. So everything is understand after discussing this seismic waves. चलो आगे बढ़ते हैं. So next one is, after discussing the upper mantle, let's discuss about the lower mantle. So lower mantle, it's extend from 660 km to 2900 km. This is solid due to extremely high pressure. देखो मैं आपको एक अच्छा चीज़ बताता हूँ. सो वेदर द मटेरियल इज गोइंग टू बी सॉलिड स्टेट और लिक्विड स्टेट, हाउ इट इज गोइंग टू डिसाइड. लिसन वेरी केयरफुली. लेट्स से देयर इज ए, ले लो, टेक अबाउट द आइस. आप आइस को ले लो. आइस को लेने के बाद आप क्या करते हो? पानी में गर्म करते हो, हीट करते हो. इट इज एन आइस स्टेट. व्हेनेवर देयर इज अ राइज इन टेम्परेचर, द आइस विल बी मेल्ट डाउन एंड बिकम वाटर. सो वी कैन से दैट with giving more temperature, the volume is increasing, and if you keep heating the water, it will be gas and further expand. Okay, so we can say two important factors that decide the solid or liquidity. One is pressure, another is temperature. देखो, if you keep on increasing the temperature, the material changing from solid like ice to water. Further, if you keep on increasing temperature, then it can convert it into what? Gaseous form and vaporized. सेम थिंग हैपन इन केस ऑफ प्रेशर ऑल्सो. देखो whenever any, आई थिंक आपने लिक्विड, आपने घर पे तो एलपीजी होगा ना, घर पे एलपीजी हमारा सबका है. सो आप जब एलपीजी को देखते हो, कभी आपने देखे होंगे जब हम चेक करते हैं ना, तो वहाँ से लिक्विड आती है. बट जब हम जलाते हैं वो गैस निकलती है. कैसे होती है? whenever any gas, if you compress that gas is having molecule, they are distance molecule. If you compress all this gas, then they convert into liquid. And if you further compress that, then it will convert into solid also. So we can say that with increasing the pressure, so material, or you can say it change from gas to liquid to solid. So this two factor, pressure and temperature, is going to decide whether it is going to be solid or liquid or plasma state. So outer layer of mantles, that is asthenosphere, it is in the plastic states because their pressure is not that dominating. But in lower mantle, whenever pressure is very high, that means it is compressing the material to a solid state, and temperature is trying to expand that. But here the pressure is dominating. Pressure don't give the expanding to this material. So that is what led to the solid material we found on the lower mantle. So material here you can see is extremely high pressure even though temperature are very high. So it is the pressure who is dominating. So that is what led to the solid. That is what led to the solid state. So material here is denser and less ductile. So here it is very dense material. Less ductile means you cannot break that. So play key role in mantle convections, and which is drives the plate tectonics. So this layer actually play important role in mantle convections, or that is their driving force. They are providing the energy for plate tectonics movement. चलो, तो next is mantle role in geodynamics. So mantle acts as a driving force behind plate tectonics. So convection currents generated by heat from the earth core cause the movement of lithospheric plates. This movement leads to the geological process such as earthquake, volcanic activity, mountain building, and continental. So generally all this energy that we are getting from the earth interior, it is origin from the earth core, and from that earth core through the convection current it is reaching up to the mantle, and from mantle is driving force behind the movement of all these plates, and these plates are interacting with one another, led to the development of plate tectonics. So next thing is about the core. Okay, the earth, third layer of the earth is called core. Okay, the core is the innermost and most dense layer of the earth lying beneath the mantle. So below the mantle we have the core. So understanding the core primarily based on the seismic analysis. So we can say that after all this observation we have analyzed so far, it is the seismic analysis. It is the seismic analysis that really help us to get lot of idea about the real composition of the earth interior. So particularly the behavior of the P wave and S wave, which change speed and disappear entirely as they pass through different layer. I know that this P layer, S layer, now you don't have any much idea. As the time progress, so I'll help you to understand all that. For timing you can ignore it. Okay. So core play vital role in geodynamics, particularly in generating earth magnetic fields. देखो, core is in earth. I think you know that earth is having a magnetic field. So north pole, south pole, and this is what helping us to compass directions. So and how they are getting this magnetic field, and this is getting their magnetic from earth core. We are going to discuss that as time progress, but this core is composed of iron material, and because of that, whenever, I think you know that if you are having a little bit of idea, whenever this is an iron material, whenever we are separating a current, whenever we are giving a current to any the iron, so there will be, this is an iron material or magnetic material, so there will be flux. That is what led to the formation of a pole, north and south pole, and that is what actually happened inside the earth. So for magnetic, to create this magnet, what we need a magnetic material of iron, manganese, cobalt, and that is being provided by our core. Okay. So we can say that all our earth magnetic field we can trace to our core. So dear student, tell me why all this magnetic field of earth is only decided by our core? Why not mantle? Why not crust? Tell me in the comment box and let me see how many of you are able to answer this question. Chalo. So next one is about the core, begin at a depth of 2900 km, marking the boundary of mantle, and this boundary is called Gutenberg discontinuity. So first discontinuity between core and mantle, it is called Mohovicic discontinuity, and here it is called Gutenberg discontinuity. Whenever, let's say there is a water, let's say this is water and this is my finger. So if I am dipping, so from air I am traveling to water, so that means there is a discontinuity. Same thing happens here. Whenever you are traveling from. Chalo. So next is, so it extends the center of the earth around. देखो the core is, if this is the portion of the earth, this is the core and this is the mantle, and this is, let's say this is the crust, this is the mantle. Okay? So let's say this is the outer core, and this is extending from 2900 kilometer to 6400 kilometer. I think there is a issue on voice, so I forgot to use mic. So whenever you are having any issue, please comment in the comment box, otherwise it's very difficult for me to know what's going on. ठीक है? Yes Alex, I think you have raised your hand. बताओ. चलिए आगे बढ़ते हैं. आई एम रियली सॉरी, इन बिटवीन आई जस्ट फॉरगॉट टू यूज माई माइक, सो माइक वॉज देयर, सो लिटिल बिट ऑफ नॉइज वॉज देयर, सो आई एम रियली सॉरी फॉर दैट. So please let me know if you all are in live, so please let me know what kind of problem is going on so that I can have idea about all these things. Okay, चलो आगे बढ़ते हैं. आप नहीं बताओगे तो पता नहीं चलेगा. चलो next. So we can see this extend from 2900 kilometer to 6400 kilometer. Thus the core is approximately 3500 kilometer in radius. So core is densest layer. So सबसे ज़्यादा dense कहाँ आपको देखने को मिलेगा? core में देखने को मिलेगा. So the increase in density is due to compaction of heavy metals under extreme pressure. So whenever we are, let's say we are taking, so let's say this much of material and then we are compacting within a small space because of high pressure. So that is what led to the more denser material we found at the core. ठीक है? So it's mainly composed of nickel, iron, hence so core is composed of nickel and iron. So hence the core is often referred to as, क्या उसको बोलते हैं? नाइफ. नाइफ का मतलब निकेल, Ni का मतलब निकेल, Fe का मतलब होता है आयरन. सो नाइफ का मतलब वो चाकू नहीं होता है. सो हियर दे आर यूजिंग ऑन द बेसिस ऑफ निकेल. निकेल का नाम क्या होता है? Ni होता है, एंड आयरन का Fi. सो नाइफ लेयर. सो इट में कंटेन लाइटर एलिमेंट लाइक सल्फर, ऑक्सीजन एंड सिलिकॉन इन स्मॉल अमाउंट. सो if there is a question, if there is an absolute question in core of the earth, it comprises of only nickel, iron. The answer is wrong because there can be found small amount of sulfur, oxygen and silicon. You have to refer that. Okay, you have to understand that. Although core is vast, it makes only 15% of earth total volume. We can see only 15%, but it is having 33% of its weight because here we found all these heavy materials. ठीक है? So because of that it is heaviest layer. So the core is divided into two distinct soft layers based on the behavior of seismic waves and physical state of material. The core is further divided into two layers. One is called outer layer, and another is called inner layer. So if this is the, let's say this is the, I am redrawing that. This is the entire core, and core is divided into outer core, and this is called inner core. Okay, so we have to understand their properties, we have to understand their difference. Okay, and this is, we can draw this as a crust, this is, we can say, mantle. Okay, the upper mantle and lower mantle. Okay, so that is what the diagram we have seen. So outer core is in liquid state. How come outer core is in liquid state? Because in outer core it is the temperature dominant. Whenever temperature is very high and pressure is low, so at that time we can found liquid state. I have already told you, if you keep on increasing temperature, so the material will shift from solid to liquid and then gas. If you increase the pressure, then gas will be converted into liquid and then solid, just like your LPG cylinder. They are gas, but this is compressed and put in the cylinder. So because of that, whenever you can find liquid in your hand also. I think आपने अगर कभी गैस को खोले होंगे, चेक किए होंगे, then आपको liquid मिलता होगा. So this is what happened. It's in liquid state. So thickness extend from 2,900 km to, no need to remember all these facts and detail, but if you remember, it's very good. And AS wave do not pass through outer core, confined it. I know this AS wave, P wave, for time being you might not be able to understand that. For time being you can skip it, but later on whenever I am explaining all these things you will be able to understand that. देखो, S wave do not pass through the outer core because S wave जो होता है उसको बोलते हैं secondary wave. Secondary wave generally only pass through the solid material. Why this is happen? मैं आपको बड़े अच्छे से समझा दूंगा, बस थोड़े से पेशेंस रखना. And primary wave जिसको हम बोलते हैं P wave, जब P wave can pass through all solid, liquid and gas, but thing is that its speed is more in the solid than liquid and least in the gas. So its speed, primary wave speed is more in the solid, then reduce little bit on liquid and then further reduce in the gas. So this is what speed. Okay, so however P wave slow downs significantly, creating shadow zones. You can see whenever P wave and S wave they pass through the outer core, so P wave is passing but it is slowing down, but whenever S wave is passing, whenever S wave is passing through the outer layer, so it is not able to propagate further because S wave can only propagate through the solid layer. ठीक है, आगे बढ़ते हैं. So you can see it's primarily composed of molten iron and nickel, and this movement of liquid metal outer core responsible for generating earth magnetic field through dynamo effects. So let me explain that how the movement of outer layer is actually helpful for generation of earth magnetic field. So how you are going to get a magnet? So if you study about physics in your 10th or 8th class, so I think you know that whenever we are taking a magnetic material, ये क्या है? This is what called magnetic material. हमने एक magnetic material लिए, and in that magnetic material what we can do, we can use some wire to give some currents. You can connect a DC battery and give some currents. If you are giving this current, so there will be circulation of currents. Whenever there will be a circulation of current, there will be magnetic field will be there. So that is what led to the formation of poles. And if you bring an iron material, so it is going to attract towards it. Okay, so it became a magnetic material. Same thing is also happen inside our earth also. देखो, earth core is composed of this. We can compare this iron material with the earth core na, outer core na. देखो, to get a magnetic field, what you required? You required a magnetic material. Magnetic material can be iron, nickel, cobalt. there are other material as well, but these are generally considered as a natural magnetic material found in abundant. Okay, so iron, nickel, cobalt, so already there in the outer core. Then you need a current, for magnetic field, but you know that earth is moving and outer core is liquid. Because of this earth movement and outer core is liquid, so liquid is also moving around this magnetic material. So this movement actually create a convection current. This current and magnetic material led to the formation of earth magnetic field, and that is the reason we consider our earth this is a north, this is a south, but in reality this is not the real polarity of the earth, and generally the actual polarity we found on the top is actually south. If you see, this is the earth, let's say this is our earth, the real polarity we found on the north side, it's actually south. The real polarity we found on the south side is north, but we generally take this as a north and bottom as a south. Why we are taking this? We are taking this as a south. Why do we are taking this? Because our compass, whenever we are using compass, it will attract, north pole will attract towards the south pole. Whenever we are using compass, our north pole will attract towards south pole. So because of that, it is showing direction like that. So north pole is showing direction towards top, and our south pole will be compass south pole will be attracted towards the north pole. So because of that, whatever direction we are giving, it is reversal of earth original direction. Okay, so remember that. So I think you are able to understand that how the magnetic field is generating through dynamo effects. चलो आगे बढ़ते हैं. So outer core is generally composed of, Alex, I think you are able to understand or not. Please write in the comment chat box if you are facing any problem, so I will help you on that. ठीक है? And any student, if you are having any issue, please let me know. If anytime you are facing any audio, video, any issue, so please let me know. By knowing your comments only I can help you to improve. चलो आगे बढ़ते हैं. So next is inner core. So after discussing the outer core, let's see inner core. We know that outer core is outer core is composed of solid state. Here it is, outer core is composed of liquid state. So inner core is composed of solid state. So it's extend from around 5150 km to 6370 km. So center of the earth. So P wave. So I already have told you the primary wave, it can travel through solid, liquid, gas. So primary wave is like sound wave. If I am saying something, it can travel through solid, it can travel through the liquid, it can travel through the gaseous medium. And secondary wave is like water wave. If we are throwing a stone on the pond, so there will be ripple. So this is what like water wave. So secondary wave is not traveling through liquid and gas, it can only travel through the solid material. Okay? So P wave travel faster than outer core. However, S wave can partially transmitted due to solid state. So you can see the primary wave will transfer more faster if dense material is more denser. If material is light denser, then P wave will not transmit. Transmit at less speed. But S wave, there is a restriction. Thanks Alex for your information. Yes, very good, everything is good. Chalo. So P wave, let me give you little bit of detail about P wave and S wave, then we can further proceed. I think that is what going to create lot of doubt. So P wave is called primary wave. इसको हम क्या बोलते हैं? Primary wave. Primary wave is just like sound wave. साउंड वेव कैसे होता है? जब आप क्लैप करते हो, क्लैप करने के बाद क्या होता है? इट कैन बी ट्रैवल थ्रू द सॉलिड मीडियम, इट कैन ट्रैवल थ्रू द एयर, इट कैन ट्रैवल थ्रू द लिक्विड ऑल्सो. लिक्विड में जाती है, जैसे सोनार होता है ना, साउंड सोनार हम यूज़ करते हैं कहाँ? सबमरीन में. ठीक है, सोनार भी यूज़ करते हैं. बट द स्पीड ऑफ दिस वेव विल बी मोर ऑन सॉलिड. सॉलिड में बड़े फास्ट जाती है, देन लिक्विड, देन गैस. ठीक है, बट व्हेन इट कम्स टू द सेकेंडरी वेव, you can see, so they are they are like, you know, they are like perpendicular wave. We are going to see that in detail. So it can only pass through liquid, only move or pass in liquid, only pass in solid, not liquid, sorry. It can only pass in solid, it cannot pass through the liquid and gas. So whenever there is a liquid, so this wave, there will be blockage of that. Okay, so we can see here the primary wave travel faster than in the outer core. However, S wave can be partially transmitted due to solid state. So this is what actually, so it's primarily composed of solid iron and nickel with extremely high pressure. So there might be a question, so outer layer is solid, but how inner layer is, so outer layer is liquid, how outer layer is liquid, how inner layer can be solid? The inner layer is solid because of extremely high pressure. Here the pressure is dominating the temperature, so because of that we can see the state. So here estimated temperature reach up to 5000 to 6000 degree with immense pressure, preventing the material from melting. So because of high pressure, देखो temperature want to expand the material and melt down the material, but pressure want to bring together. So because of that मटेरियल इज इन सॉलिड स्टेट. मैं आपको एक एग्जांपल देती हूँ. जैसे आपने प्रेशर कुकर देखे होंगे. प्रेशर कुकर में क्या होता है, वेन एवर यू आर कीप ऑन इंक्रीजिंग द हीट बिहाइंड, सो इट इज ट्राइंग टू एक्सपांड एंड इट्स ट्राई टू कन्वर्ट वाटर इनटू वेपर, बट pressure cooker prevent vaporization, and this is happen because of high pressure. Whenever you are putting high pressure and the temperature want to expand that, so that is what led to the material will be solid even at high temperature. So this is what you have to remember. Inner core is solid, outer core is liquid state. Okay, so there can be question also. So the seismic discontinuity are boundary within which rock property changes abruptly. So we have seen that whenever we are moving from core to mantle, we know that density of core is 2.7 in crust, 2.9 in mantle. So as we move towards mantle, density is increasing from 3, 3.2, 3.5. So there is a sudden change in discontinuity. So that is what we have to understand, and there are different discontinuity we are going to see. So first discontinuity is called Mohorovicic discontinuity or Moho discontinuity. So this discontinuity is found between crust and mantle. So 5 to 10 km in oceanic crust, 30 to 50 km in continental crust. Dekho dear student, this notes I am providing, they are extensive. So if you are referring to that, no need to go NCERT, no need to go any book, because all these things, everything you will find in the single notes, no need to refer any notes. Okay, so that is the reason. So please read this note multiple times, you will get all this information here. Okay, no need to refer any notes. So this is a transition from crust to mantle. So increase the wave velocity, because as the density increase, so wave velocity also going to increase. So mark the base of earth crust. So next is about, yes, I think सब नहीं चाहिए हमें, कुछ चीजें मैं पढ़ा देता हूँ. Next is Gutenberg discontinuity. So Gutenberg discontinuity is found between the mantle and core. So next is Lehman discontinuity. Lehman discontinuity, generally they are found between, you can see, outer core and inner core. So the outer core, inner core discontinuity is called Lehman discontinuity. चलो आगे बढ़ते हैं. I have given a diagram with all this discontinuity, so you have to remember. There can be questions. There can be questions of match the following type. There can be question Mohorovicic discontinuity between which two, then Repti discontinuity, Gutenberg discontinuity, and Lehman discontinuity. These four discontinuity you have to remember. So Moho discontinuity between lower crust and upper mantle. Then Repti discontinuity between upper and lower mantle. So mantle के बीच में जो discontinuity होती है उसका नाम क्या है? Please remember. The next is Gutenberg discontinuity between lower mantle and outer core. Lehman between outer core and inner core. So please, there can be, remember this diagram. There can be questions on discontinuity. Dear student, please let me know whether everything is okay or not. So my voice, audio, everything is okay or not. So please let me know. So the increase in density is. चलो आगे बढ़ते हैं फिर. So next is temperature, pressure and density of earth interior. So how they are changing as we move inside the earth. Let's say this is the earth. Let's say this is the earth and we are moving deep inside. Let's say this is the different layer, inner core, outer core, then this is the mantle, inner mantle, outer mantle. So if you are moving inside, how the temperature, how the pressure and how the density is changing. So that is what we are going to see. So first one is temperature. We can see temperature increase with the depth. As we move inside the earth, there will be increase in temperature. Why? Because all this energy, all this heat that is we are getting on inside the earth, they are getting from the core. So and this heat is traveling through convection current in all directions. So if you move towards core, so there will be rise in temperature. So temperature will be rise rapidly. So temperature increase with the depth but not uniformly. So steep near the crust. So temperature increase will be very fast or rapid near the crust, but moderate in mantle and very high in the core. So this can be a good statement in examination also, because now exam is very much evolving. So you have to evolve. So you cannot wait and just for sake of understanding read something. So you have to understand, read very thoroughly. So the core temperature is estimated to between 300 degree to 5000 degree due to radioactive decay. So why from which source our core is getting all its energy? देखो earth interior, all this you can say endogenic forces, they are getting their energy from earth core. And from where they are getting energy? They are getting energy because of radioactive decay. Some of the radioactive element on the earth core, they decay to release all this energy. Second one is residual heat from earth formation. So initial days earth was like a light bulb, it is a hot bulb, but with passage of time the outer layer they became cooled down, but the temperature that still inside the earth, that is also called residual heat, they are still driving. Next is chemical reaction under high pressure. Because of high pressure inside the core, so there can be lot of chemical reaction. I think आपको पता होगा, जब मैं आपको बताता हूँ छोटा सा चीज़ें, जब आप कोई सोडियम को पानी में डालते हो देखे होंगे कितना जोर से वो ब्लास्ट करता है. सेम थिंग, if under high pressure all chemicals can come under single point. So that is what led to the reaction also. So if anyone ask about the question or any prelims question, from which source earth is getting its endogenic energy, you can say because of radioactive decay, because of residual heat, because of chemical reaction that is happening inside the earth interior or earth core. ठीक है, hope it is clear. So 2 to 3 things you have to remember as we proceed from crust towards core, temperature is keep on increasing and this is not uniform, and steep near the crust, then moderate in the mantle and very high in the core. And how the core is getting its temperature? Core is having all the energy, all the temperature we are getting in the earth, it's having its origin in the कहाँ होती है? core पे होती है, and the temperature of the core is very high, it is reaching up to 500,000 degrees Celsius. So this is happened because of radioactive decay. Why this is happened? It's because of radioactive decay, it's because of residual heat, means heat that is yet being trapped inside the earth, and because of chemical reactions. Next one is about the pressure, how pressure is changing within the earth. So pressure rise steadily within depth from surface to the core due to weight of underlying rock. For example, if I am putting, let's say, too much of weight on your head, so there will be more pressure on your head. So same thing. So because of layer by layer rocks are there, so because of that we are putting more pressure. So we can say that on the crust, if you are moving inside, so there will be more heavy weight is falling on that layer. So more deeper you are going, there will be more pressure. So you can see it reaches up to 3.5 million atmospheric pressure at the core, so influencing behavior and seismic activity. So density, you can see the density increase from 2.7 gram in the crust to 13 gram in the inner core. So this increase due to compression of material under pressure and presence of heaviest element like iron, nickel, deeper layer. देखो surface crust is composed of lighter elements, so because of that density is less. देखो if I am taking this much cotton आपको पता होगा cotton, and then this density is very less, but if I am compressing that cotton within this, so density will be high, weight will be high. So same thing happen in crust, lighter element is there, there is no compression, no pressure, but as you move inside the core, so there is a heavy weight that is falling over that layer. So because of that it is keep on compressing. When it is compressing, so density is very high and weight will increase. ठीक है, so that is what ठीक है. So next we are going to see earth movement and measure landform. So this is about earth interior, and after some classes I am going to discuss about origin of the universe, क्योंकि सबसे पहले क्वेश्चन आती है कि हम कहाँ से बने, मतलब अर्थ कैसे बनी. मैं बोलूँगा सोलर सिस्टम से, आप बोलोगे सोलर सिस्टम कैसे बनी, मैंने बोलूँगा फिर गैलेक्सी से, आप बोलोगे गैलेक्सी कैसे बनी है. So to answer all these things we are going to see that as well, but it is little bit of a difficult topic. So I want first, it should not create an impression that geography is very difficult. Once we are comfortable with the geography we will see that. Is that okay to everyone? समझ में आ रहा है? चलो आगे बढ़ते हैं. So if my voice is audible or not, everything okay or not, please let me know. So next is the earth surface is perpetual. देखो the earth surface we are seeing, it is not in that perpetual state. बोलते हैं ना कि rise and fall of empire. So the mountain, today the Himalaya is the loftiest mountain. जो बड़ा सा mountain हम देख रहे हैं आज हिमालय, maybe 20 year 30 year down the line, maybe after some time, maybe after 20 million year, 30 million year, hundreds of million years, maybe this Himalaya might be a plain. The Aravalli, I think the mighty Aravalli, the mighty Vindhya, that currently we are seeing as a small mountain, maybe at some point of time larger than the Himalaya also. So that means earth surface not in a perpetual state, it's a perpetual constant state, rather they are in the transition, constantly modified. देखो one force that is within the earth, it try to build the mountain, another force on the surface of earth, it want to erode that. So this eternal fight between endogenic force try to build something, exogenic force try to destroy that. This eternal fight between endogenic, exogenic led to the all these different landforms that we are finding on the earth surface. कैसे चल रहा है सब? बढ़िया, एकदम मस्त, या फिर कोई issue please let me know. चलो, so you can see earth surface is perpetual state of transformation. This dynamics nature stem from internal endogenic and exogenic force, each playing pivotal role in sculpting the diverse physiology feature of observed today. So if you are seeing diverse feature, for example somewhere we can see a gorge means deep, बोलते हैं ना कि एक हिमालय आप कभी गए होंगे तो आपने देखे होंगे जहाँ पर there is a steep cut happen and within that a river is flowing. So this is what called gorge. Okay, so this force govern the process ranging from violent upheaval mountain to gentle weathering of rock, so culminating shape of major landform. So we can say that geomorph, this process is helping for reshaping our earth surface. So types of mountains, so if you see types of mountains, so there are multiple types of mountain is there. So we have categorized this mountain into different categories. So first one is called fold mountains. So fold mountains happen because of how this fold mountain is happen. Let's say this is a plates, this paper is a plates. So whenever there is compression force and acting on the two side, you can see it's folding upward. So that is what led to the folding, and folding mountain create big large mountain like Himalayas, like the big mountain you are seeing, it is because of folding. So the form by compressional tectonic force. What do you mean by compressional? Let's say this is a plate and we are compressing it on the both sides. So that is what led to the folding. That is what led to the folding of this mountain, and this is portion is rising and this portion is looking like a mountain. This portion is looking like a mountain. Okay. So if you compress on the both sides, then there will be folding and formation of this mountain is called folding mountain. You can see here both compressive force led to the rise of So this is what called fold mountain. Okay, so you can see here. First, I think this is very good diagram. So we can see the mountain can be categorized into fold mountain, plateau mountain, volcanic mountain, and a dome mountain, fault block mountain. So if there is a question, what are the different types of mountains? You can say fold mountain, then you can say about plateau mountains, volcanic mountain, dome mountains, and fault block mountain. So let's see about first about the fold mountain. This is happen because of when compressional force is acting on both sides, that is what led to the folding of the mantle, the plate. So that is what led to the fold mountain. Okay, they are often referred to as young mountain. They are often called as young mountain. Often means not always, sometimes. So that is the reason our Himalaya is also called as young mountain. हिमालय को हम क्या बोलते हैं? यंग माउंटेन बोलते हैं, ड्यू टू देयर जियोलॉजिकल यूथ एंड आर कैरेक्टराइज्ड बाय टावरिंग हाइट. Their height are very high. So these are the features of fold mountain. So there can be questions. So consider the following statement, and this above statement describe which type of mountain. So first one is they are called young mountain, and their geological youth and towering height, sharp peaks and complex geological structure. So these are the features of fold mountain. So occur at convergent plate boundary. That means whenever this is a plate and another plate, they are interacting. This plate and this plate, they are interacting or they are compressing. So because of that, there will be fold at the joining point. There will be fold at the joining point, and you can see here also. So converging plate boundary. So we can say that wherever we are seeing there is a fold mountain, so that means there is two plate. So whenever two plates, you can see here, one is this one and this one, whenever they are meeting and compressing one another, that is what it is rising and forming this big fold mountain like this. So we can say all the fold mountain, they are showing the banded, they are showing the joints of two plates. So Himalaya is joined between you can say Indo-Eurasian plates with Indo-Australian plates. The Ural mountain is showing the joint between, you know, the Eurasian plate with you can say about North American plates, or you know, the Europe. So because of that joint, so Ural mountain is formed. Okay. So next is the convergent plate boundary, continental or oceanic, where long sedimentary accumulation. So we are going to see little bit of later, because you know geography is such a thing that you need to know everything, but you know it's not possible to explain everything. As we time progress, you will understand everything. Okay. Okay. So first one is about the fold mountain. So what are the characteristics of the fold mountain? I know that some of the terms you might not able to understand at this point in time, so have the little bit of patience. With the passage of time, you will able to understand all the meaning of this key terms also. Okay, chalo. So next thing is about the fold mountain. So what are the characteristics of fold mountain? So they are lofty peaks. For example, Himalaya peaks are sometimes more than 8 kilometers. So deep valley means if this is the mountain, then this is the plain area. This is what called plain area or valley area. Rugged, if you see Himalaya mountain, you can see their ruggedness. Then steep terrain and high seismicity. Even the Himalayan region, they are prone to high magnitude earthquake. I think you know that Nepal earthquake, so devastating, it killed large number of people there. So and tectonic activity and parallel ranges and complex topography. So these are a few features of fold mountain that we are founding. So these things you have to remember. There can be question, there can be, you know, these feature will be given and they can ask about these are the feature of which type of mountains, like fold mountain, fault mountain, plateau mountain, residue mountain. So if you are having confusion, you will commit mistakes. So while teaching, I am giving you all this question, possible question. Okay. So next is types of fold mountain. You can see there are multiple fold mountains, so no need to go all these things, but some of the difference you need to know. Okay, so this material I have given extensively. Some of this rising portion in fold mountain is a wavy shape. Okay, fold mountain is a wavy shape. The rising portion is called anticline, and this down trough is called syncline. Please remember that, this is going to be very much helpful. Okay, anticline and syncline. You can see two plates. So here one plate, another plate is coming. So because of that, this portion is rising and forming Himalaya, and this portion is Indo-Australia plates, and this is Eurasian plates. Okay, so anticline fold, the different types of anticline fold, just need to know about here. Asymmetrical fold, just need to know about just see the diagram and understand what kind of fold. So this is going to be very helpful, and some of the mapping that you need to understand. So first one is, this is your homework, so you have to map Himalaya. You have to identify which location Himalaya mountain is there. You have to identify where the Alps is, where Andes, where Rockies, where Ural and Aravalli mountain is. So I am going to show you about little bit of fold mountain detail for your mapping. So this PDF you should map. So DIY mapping, that means you have to do it by yourself. So Caucasus mountain, then Scandinavian mountain. So highest peak I have given this mountain. So please map that and found. So Elbrus, it's found in Europe. So located between Black Sea and Caspian Sea. So you have to map the Black Sea, you have to map the Caspian Sea. Don't worry, as time progress, I will also map this thing. This is your homework. At least do mapping of that, and tomorrow I'll show you some of this diagram also. Okay, so Carpathian mountain, then Ural mountain, Hindu Kush mountain, Himalaya, Arakan, Yoma, Kunluncha mountain, Rockies mountain. So all these things you have to do. Then Appalachian mountains. Please search this location, and tomorrow I'll show you some of this location. Okay, Sierra Nevada, Alaska range, Altai mountain, Andes mountain. So I think I have given some of them. This is called Great Dividing Range of Australia. Great Dividing Range of Australia. Great Dividing Range of Australia. This South America, the mountain is called Andes mountain. This is a fold mountain. Here it is called Great Dividing, it is called Andes mountain, and here this mountain is called Rockies mountain. Okay, and this eastern side is called Appalachian mountain, and this mountain is very much important from in USA because of mineral rich, and this region is industrial rich also. So next one is about, this is Himalaya, this is called Atlas mountain. Okay, so I think there are a lot of mountains you can see here. So this is Ural mountain, located between, this is Russia, this is Eurasia, Europe. So this Ural mountain is acting joint between Russia and Europe. So Hindu Kush, this is what called Hindu Kush, Zagros, Taros, Altai, Karakoram. So you can see Tian Shan, Caucasus mountain, Alps, Pyrenees, Apennines. Okay, so please map all this location, because from geographical perspective mapping is very much important. Without knowing mapping, you will not able to get good marks in prelims or mains. So you need to know about mapping, because nowadays UPSC is asking very tough question, even OPSC is asking very tough question. Even if you are getting one or two question, you have to correct that very 100% accurately, so that you will able to clear your examinations. So second category of mountain is called block mountain. Second category of जो mountain होती है उसका नाम क्या है? Block mountain. I think ये block mountain जो है हम कल पढ़ेंगे. Actually I am moving little bit of slow, so that I am giving you time to understand, because initial starting should be very slow, gradual, and definitely as time progress will proceed little bit of faster. Okay? So please study whatever I have discussed so far very thoroughly, and as always tomorrow we are going to have our class from 7:30 to 9:30. Okay, so and this is going to be live stream both in our application. So those who are our students, so you can, those who have already joined our, so either you can join the live or you can watch the recording, and this session is also going to live in the YouTube also for some days. So if anyone want to know about the how demo of that lecture, so you can watch that for some days. After that you can join our foundation batch. But thing is that OPSC is given opportunity to everyone, so now they are increasing the age, so don't waste it opportunity, better prepare so that you can clear this examination this year itself. Okay dear student, चलिए, विल हैव टू एंड हियर. बाय बाय, टेक केयर, जय हिंद.